Now students, our next topic is formula for the speed of sound. Okay, so you have seen that how the sound is traveling from one place to another, and with that it is taking time also. Like we have seen the at 20 degrees centigrade, what was the speed of sound? It was 340, around about 340, 344. It is going to be variant, like weather and climatic conditions are going to be changed from place to place and time to time. So we can say that speed of sound could change accordingly. Okay, so but we can calculate it. So what was the formula? How can we transmit that the speed of the sound is like this only? Okay, so we know that speed is the distance upon time, that I have already written and shown to you. Okay, so you know that we can write it like this: speed is equals to distance multiplied by 1 upon time. Okay, this here 1 upon time is going to be indicate something that we have done in earlier part. What is it? Okay, you know that distance is the part of wavelength. Like if I see the wavelength here, like the diagram that is denoting the sound waves. So distance, what is distance? So how we will cover the part of the speed? Speed will be distance upon time. So distance would be one wavelength. One oscillation is covered in that much of time. Then we can say that the speed is this. Okay, like speed is equals to distance upon time. So if we see that one oscillation, one wave is covered in that much of distance and with this time, so we can just calculate, though we are not taking a large distance and large time. We can do that also. With that also you can find the speed of sound. But in case of the, like now we have just seen these wavelengths of the sound and we have seen all graphical parts, so we need to take with this thing. Okay, like you are getting a question according to the wavelength and according to the time that is given. So then how you will find the speed? Then you just put the values here and easily you can find. So this is the wavelength as we have seen, and frequency is 1 upon time. If the exact time of completion of the one oscillation is not given to you, like the time period is not given to you, so what you can do? You can do that, you know, time period is equals to 1 upon frequency. Okay, and if we cross it, like frequency part will go here and this time period part will come here. So what is it? The frequency will be equals to 1 upon time period, and that is the again time that is taken by the wavelength to complete one oscillation, or we can say taken by the particle to complete one oscillation. Okay, so here distance is for one wavelength, time is for one wavelength, and if time is not mentioning, so we can take the frequency part, that is 1 upon t. So now you know that the speed is equals to distance upon time. So speed will be distance multiplied by 1 upon time. Here this 1 upon time now become frequency, like this. Okay, so what we get? We get the speed is equals to wavelength multiplied by frequency, and that is again wavelength. Speed is equals to velocity, we can indicate with the symbol v, and wavelength is the lambda and frequency is f. So this is the general formula that is going to be used in solving question and answers. So see students, as we have discussed now the speed of thing, and what we have learned, v is equals to lambda multiplied by f, that is the frequency part. Okay, and this is v. Okay, so here even you can write like this, even in some book it is mentioned like this, v, proper v is equals to lambda multiplied by, this is frequency, this it could be a symbol of frequency, that is not v. Okay, so according to this, now let us see different characteristics of the sound. Okay, like loudness. Loudness, as I have told you, that in the wave, the amplitude part, the more the amplitude, the more the loudness will be. And what is amplitude? The maximum displacement from the mean position. And the maximum displacement from the mean position will tell you the lambda thing. also, like it is going to be depend on the lambda part, because that much height would be traveling according to the height. The distance part would also be matter, and that will give you the wavelength. Okay, so here now we are not going to take this thing, but we are going to discuss the amplitude part here. This is the amplitude. Loudness depend on amplitude only. Larger the amplitude, larger is the loudness part. Okay, so loudness is directly proportional to the amplitude square. Like if amplitude is 1, then loudness will also be 1 decibel, and if the amplitude part is 2, then loudness automatically will become 4. How? Because it is a square. Loudness is the square of it, and 1 का square 1 ही होता है, so it is not going to be changed, and it is not going to matter at all. But in case it is going to be double, so now loudness will become 4 times of the previous one. Okay, like I have given you the example of lion roaring and a soft voice of baby. Okay, both of these are having different loudness. Baby could not roar like a lion, and lion is just roaring like it will go to kilometers away. The sound of lion could go to that much of distance. Okay, so that is the part of loudness. Now let us see the different thing, that is pitch. Now, as I have told you, pitch depends on the frequency part of any sound. And what is frequency? Frequency is again the part in which we can say that how many oscillations have been done in 1 second. Like here in this case 1, 2, 3, 4. So 4 is the frequency for this case. If we are taking this time period as the from here to here, if it is 1 second, so we can say that the frequency is 4 for here. Okay, so higher the frequency, we can say that higher is the pitch. And here we can easily say pitch is directly proportional to the frequency. More the frequency, like जितनी ज़्यादा frequency होगी, उतनी ही ज़्यादा shrillness sound में आएगी. What is it? Shrillness. Okay, so shrillness क्या होता है? तीखापन. Like women is having a shrill voice. उनकी आवाज तीखी होती है, and men are generally having a dull voice, though they are having a loud voice. उनकी आवाज loud होती है but dull होती है, तीखी नहीं होती है. And women की आवाज थोड़ा soft sound करती है but तीखी होती है. Okay, so they are having a sharp voice, and that is why you will see that in during the recruitment of the radio jockey also, they are going to test their pitch. Like if somebody wants to be a radio jockey and in to play a part in the video, okay, so generally their voice modulation would be checked before getting them appointed. Okay, so this is what the part, and this depends how many vibrations they are producing in a single second. And girls and women are generally having this tendency to produce more and more vibrations, and even so that gives the shrillness of the sound. Okay, now next thing is the quality of sound. So this is again like you distinguish between musical notes that is delivered by different kinds of instruments, right? Like if I play the tabla, so you will get, yeah, this is a sound of tabla. And similarly, if I play the flute, so you will get to know. Though I am playing any instrument, like I'm having a guitar and this flute and this tabla. Okay, now what we are going to do, we are keeping their loudness part and the frequency part same. Okay, तो हमने क्या किया, हमने इनकी loudness भी same रख दी कि चलो हम इनकी loudness same रख देते हैं और इनकी frequency भी same रख देते हैं. अब बताइए क्या अभी भी इन तीनों इंस्ट्रूमेंट की सेम क्वालिटी ऑफ साउंड आएगा? क्या ये एग्जैक्टली सेम अमाउंट सेम तरीके से सुनाई देंगे? नो, because their quality is different. Like in tabla, what we are using this bass. Like ये जो है आप इसका bass use कर रहे हो, stretched thing है. And in flute you are using air for the sound modulation, and in guitar you are using strings. So जब इनका origin ही different है, तो how come they are giving the same kind of sound? It is not possible. Though they are provided with the loudness, same loudness and the same frequency. Even maintaining them at the same loudness and same frequency is also still not possible. Like if I say to somebody like you have to play it on same loudness, it is not going to be possible with any kind of instrument. And even if you are taking both the instrument of same kind, like one tabla and two tabla, and if you are guessing to anybody like you have to play it on same loudness, then still that also is not possible. That is giving us the musical notes, different musical notes. Okay, and that musical notes are give us the melodious sound. That is good for us. That is good कि अगर ये same sound नहीं देते, इसीलिए we are having a variety of music things and mixing them with the high or low modulation of frequency and loudness will gives you different kind of musical notes, and that is again is a melodious sound, and that is how you are going to love these songs, different kinds of songs.